Okay, so good day to everyone who is listening. So our topic for today is correlation and regression, and it's quite simple. It's just like your Spearman rank, but this time we're going to use it for normally distributed data. Okay, so let's start with the assumptions of the test. Okay, so Pearson product moment correlation is a test we use if the data is at the interval or ratio level and there should be a linear relationship between two variables. It means that if one increases, then the other should also increase and vice versa. So if one variable decreases, the other should also decrease. So hindi pwede na habang nag-i-increase yung isa naman ay bumababa. Okay, so that would not give you a linear relationship. So dapat as one increases, the other also increases, or if one variable decreases, then the other should also be decreasing. Number three, since this is again a parametric test, there should be no significant outliers, and the data should be approximately normally distributed. Again, for those of you who are not yet familiar, when we say approximately normally distributed, what we mean is that the three measures of central tendency is approximately the same with each other, and our measures of spread is quite low. Okay, so we do have tests that we can use for normal distribution of data, but we're not going to be talking about that now because that's more of something that you learn in practice rather than an actual um, statistics lecture. Okay, so anyways, these are the four assumptions of the test that we're going to be running. Yeah, again, the data should be at the interval or ratio level. There should be a linear relationship between two variables, and there should be no significant outliers. And of course, the data should approximately be normally distributed. Moving on to the formula, it's really quite simple. It's just actually the summation of your two variables. So you have your x and y in different forms. So I'm going to show you how to compute for this in a timely and easier manner. Okay, so let's begin with the example. Now, according to the data published in the Industrial Quality Control, the relation, excuse me, the relationship between detergency, which is represented by X, and concentration, which is represented by Y, is as follows for a sample of 8 detergents. So now we know that we have 8 detergents. Okay, so our N is 8. By the way, I'm still performing the steps of statistical hypothesis testing. I'm just not writing it down. We have two variables. X is representing detergency and Y representing concentration. Okay, so again, we go through all the trouble of formulating our null hypothesis. Our alternative hypothesis, we're going to look for the tails of the test, which is normally a two-tailed test. And of course, we're going to select the test that we're going to perform. In this case, we want to know if there is a relationship between detergency and concentration. So we just want to know if X is affecting Y. So our null hypothesis is just there is no significant relationship between detergency and concentration as shown by the data below. Okay, so I'm not going to write it down anymore. At this point, you should be able to properly write down your own hypothesis. Anyways, to compute for this, the best way to apply the formula is to create a table like this. Okay, so you have x, y. These are just simply our variables. These are the given variables. You have x times y, you have x squared, and you have y squared. Okay, so simply 37 times 10, that's 370. 42 times 20, 46 times 30 is 1380, and so on and so forth. So yun lang po yung gagawin natin. And then of course, you have your x squared, which is just the square of 37, y squared, which is again the square of 10. So gagawin lang po natin yan for the whole of our data. And of course, at the end, we're going to get their total. Okay, so very simple computation. Konti lang po yung kailangan nating apply. So this is quite an easy computation for us to make. So then all we have to do is apply this to the formula. So again, it's R is equal to N, which is 8 times X, the total of X times Y, that's 9, 7, 10, minus the summation of X, which is 451, times the summation of Y, which is 170. Okay, divided by the square root of, okay, apologies for the very crude drawing. Again, that's N times the summation of X squared, which is 27,503, minus X squared, or the summation of X squared, that's 451 squared, times, do this again for Y, that's 8 times the total of Y squared, which is 4,500, minus 170 squared. Okay, so now we're going to apply and we're going to perform the operations. So you could input this directly in your calculator. Just make sure that you don't forget the parentheses and the brackets, because that's going to give you the proper order of computation. So if we apply this formula, computing for it, we're going to get a value of 0.09. Now, when we conclude, there are two things we're going to check. So the critical values of Pearson R and the descriptive interpretation. Okay, so let's look at now our conclusion. Now, I've recently given you the critical values for Pearson R, so we're just going to do the descriptive interpretation. Now, our result is 0.09, which falls within the range of 0.01 or 0.2, which is a negligible relationship. Okay, so therefore, detergency and concentration has a negligible relationship. Okay, this means that they do have a relationship. However, it's not significant, or it's rather not as much as an effect as we want with each other. So that would mean, or that would be given a description of negligible relationship. Now, if you're going to look for the critical values of Pearson, you're going to have to do n minus 2. Okay, n stands for your observations. And we're going to subtract 2 because we're actually looking at two different variables. Okay. In this case, in our example, we're looking at X as detergency and Y as concentration. So that's the reason why we subtract 2. Okay, so that's how you get the degrees of freedom for our Pearson correlation. So that's about it with our Pearson R correlation. And the next thing that we're going to do, so for instance, let's say that we've established a very high positive relationship for our Pearson R. So just an example, we can move on to what we call regression. So I'm not going to teach you the computation for regression, perhaps because it's a bit complicated for at our level. So usually kapag ganito na po yung level ng statistical treatment na kailangan, gumagamit na po kami ng more advanced statistical software. So regression is a form of linear prediction, which involves one predictor variable and one response variable. So for instance, yung x natin and yung y, x sa example natin is our detergency and y is our concentration. So this is one thing that we have to consider with the regression is before we perform it, we have to have a high correlation. Okay, the reason for that is because we actually use regression to predict a certain value For instance, binigyan tayo ng value ng x ng 10. That's going to allow us to predict our concentration. For example, ang concentration natin is 40%. Something like that, no? It allows us to give a formula as a predictor for our next observation. So that is why we have a predictor variable and a response variable. So in this case, let's say that x is our predictor variable. So i-compute natin ngayon, if x changes, pag nagbago daw po yung x, anong mangyayari kay y? Okay, tataas ba si y or bababa? So that is why we call y a response variable. So this will give us a model of prediction where we can determine a dependent or response variable using the independent or predictor variable. So for example, meron tayong data set. Let's say data set A and B. Then na-establish na natin, or we've already established that A affects B. So meron tayong data, 10, 20, 30, 40, and then si B, sabihin natin 100, 200, 300, and 400. Okay, so just an example, we have a data like this. Meron tayong 4 different variables, 10, 20, 30, and 40. And then si A daw yung predictor natin. And si B yung response natin. This means that our predictor variable also can be referred to as your independent variable, and your B is your response variable, also may be referred to as your dependent variable. Kapag nagbago daw po yung predictor natin, si A, anong mangyayari doon kay B? So, let's say, ang A natin ay naging 50. Okay, so very simple, no? Based on the correlation that we've established and the data we have, we know through common sense na ang sunod po or ang katumbas ng 50 natin ay 500. Okay? So we have this established correlation. Pero paano kapag hindi pasok doon sa common sense natin yung value ng predictor variable natin? Sabihin natin may lumabas na 67.21. Okay. So, ano daw po yung mangyayari kay B or ano yung magiging value ni B kapag ang A natin ay naging 67.21? So, doon na po papasok yung regression formula natin. So, y is equal to A plus B x. This would be the formula that we're going to use. This, by the way, is not the formula for regression. This is not how you compute regression. This is just the formula that we're going to use for our response variable. Okay. If our y daw, y is our predictor, is a certain amount, what happens to A, what happens to B, and what happens to X. So these are the two variables that we're going to be computing for when it comes to regression. So si A daw, tsaka si B ang kinocompute natin. And that would give us the value for X and that or y. No? So pwedeng either or of the two. As long as we have our response and our predictor variable, we can predict kung ano yung value ni y and ano yung value ni x kapag meron tayong given variable. Okay, again, si A at si B po, these are what we compute for in regression. Okay? We also have multiple forms of regression. Pwede tayong mag-simple linear. So simple linear, isa lang po yung predictor natin, just one predictor. We could also have what we call multiple regression. Multiple regression. In this case, marami na tayong predictor variables. Okay? We have, for instance, meron tayong predictor variable x, y, z. And then our response is isa lang. A. So, si x, y, and z daw ay pwedeng apektuhan si A. We've established this using correlation. Ang trabaho naman ni multiple regression is to find out how much x is going to affect A, how much y is going to affect A, and how much z is going to affect A. So, sino daw yung may pinakamalaking effect? Sino yung may pinakamaliit na effect? At sino yung so-so lang yung effect natin? Okay, so that would be multiple regression. Again, medyo masakit siya sa ulo, but I hope you get the concept of what we refer to as regression. No? This is some sort of a predictor variable. Typically, ginagamit natin yan when we're trying to look for um, variables we can change in a correlated set of variables. No, so, paano yung magiging response nung response variable or dependent variable natin kapag binago natin yung predictor variables natin. Typically used in car sales, in sales in general, no? For instance, ano mangyayari dito sa sales natin sa isang produkto kapag tinaasan natin yung presyo? We could use regression to compute for that. Okay? So, that would be our um, last topic for our midterms. No? Pearson moment product correlation and your regression. Simple and multiple. Okay, so that would be all for our midterms. I think we've covered everything. So thank you so much for listening, and I hope you learned something new. And if you have any questions, our Discord server is always open.